Okay, so if the derivative is 2x, what is the function? Okay, so what was the function in order for me to take the derivative and get that? X squared plus a constant, right? Because it could be x squared plus 5, it could be x squared minus 10, it could be x squared plus 17 over 3, dot, dot, dot. It could be any x squared plus or minus any constant, right? Because when I take the derivative of that, I get 2x. Make sense? Okay, and so what about just x? So you're going to add 1 to the exponent and then divide by the new exponent. So here I add 1 to 1 to get 2, then divide by 2 gives me x squared. Okay, so this one, you add 1 to the exponent 1 to get 2, and then divide by the new exponent. So 1/2 x squared, and then plus a constant. Okay? All right, so what if I have x cubed, or x squared then? I'm giving you the answer, part of it. Okay, so add 1 to it to get x cubed, divide by the new exponent 1/3, and add a constant. Okay, so 1 over x squared. That's the same thing as what?
X to the negative 2.
X to the negative 2. So increase that by 1. X to the negative 1. Divide by negative 1.
Negative 1/3 x.
Okay, plus a constant. So it's just going to be negative x to the negative 1 plus a constant. Right? So you just increase this by 1 and then divide by the new exponent. Okay, so if I have 1 over x cubed, how do I rewrite that? X to the negative 3. So then the antiderivative, or so increase that by 1, negative 2, then divide by the new exponent, negative 2. Okay, so, and then add a constant. Okay, so you can write that as negative 1 over 2x squared plus a constant also. Okay. So the integral of cosine x is sine x plus constant. Okay? So if you're given the derivative, then the antiderivative is over here, just the opposites. Okay, and so that goes back to the definition that we looked at in the very beginning. A function f is an antiderivative of f on an interval when f prime of x is equal to f of x for all x in the interval. Okay, so when I can take the derivative of that and get back to the function, then it's an antiderivative. Okay? Any questions? Okay, so now let's look at some examples that have more than one term together. So this is number